Hey gang, so let's do our unit review over transformations and regressions. Alright, so I can describe how changing the slope and or y-intercept affects the graph. What is the parent function of the linear equations? Or linear, equations. Well, parent function's f of x equals x. It's plain, it's simple, it's boring. 0, 0, 1, 1, 2, 2, 3, 3. Goes through the origin, right like that. So remember, with your parent functions, it is plain, simple, and boring. Alright, so we're starting with f of x. I was eating an Oreo and it got all over here. F of x equals x, and we're going to create the baby g of x. What did we do? Alright, I'm going to tell you there are two transformations that happened here. Actually, three transformations, sorry. I'm going to start with the plus 4 on the end. The plus 4 on the end is going to be our vertical translation. And if we want, you can actually do it one by one in your calculator if it helps you. I can go to y equals, and I can put in the parent function. And then I can say, what happens if I just add 4? Don't do the negative 6. Just do x plus 4. And you can graph it. Okay, so it moved it up 4, right? So I'm going to say it moved up. Then I could say, okay, well, what if I go back to y equals, and what if I change it and I just put 6x? What does that do? Don't do the negative, don't do the 4, just do the 6. Take it one transformation at a time. Okay, so the 6, if this was a ski slope, this would be a super steep ski slope. I would be terrified on that. So it got steeper by a factor of 6. So I would say steeper by a factor of 6. And then I would say, okay, well, what happens if I just go down here and I put negative x? Don't put the 6, just put a negative. What does that do? Here's my parent function. It reflected it. So remember, the negative reflects it. So it reflected over the y-axis. Okay, so 3 changes. So let's see if we can do this one. The negative 7, that is going to make it move down 7. It's going to be that vertical shift. The 1/2 fractions that are between 0 and 1 give me a headache, and they make me want to lay my head down. So when we do a fraction, it gets less steep by 1/2. Alright. It doesn't put this here, but I'm going to put this here. If I tell you that I start with the parent function and I have a baby and the baby looks like this, what transformations happened? Well, I know that it added 3, so that means it went up 3. The other transformation is I'm here, I'm in a relationship with x, and I know that x's, man, they always lie. It says it's moving negative 2, but I know x's lie and it's moving to the right 2 units. So I just want to kind of remind you of that. When you have it in function notation, it still kind of moves the same. So a linear function f of x equals x is graphed on the coordinate plane. The graph of the new line is formed by changing the slope of the original line to 4/3 and the y-intercept to -3. Describe the steepness of the line. Graph the new line, describe the y-intercept. Well, I'm going to come down here before I start trying to graph it, and I'm going to say, okay, it says this. It says we're starting with the parent function, f of x, is graphed on the coordinate plane. So if I were to graph that 1, 1, 2, 2, 3, 3, 4, 4, I can graph it pretty quick. We've graphed it enough times. And then it says the graph of a new line. So the new line, we're going to give it a name, is formed by changing the slope of the original to 4/3. So that means we're going to change the slope to 4/3 and the y-intercept to -3. So we're taking this, we're giving it a new y-intercept and giving it a slope. Let's go over here and let's graph it. -3 would be 1, 2, 3. And then we're going to go up 1, 2, 3, 4, and then over 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Alright, let me get my line maker. Ooh. I'm going to go ahead and extend both those lines out so I can kind of see what happens. Alright, so here's my line. Let's start with the y-intercept. What did the y-intercept do? That was pretty easy to see. It moved down 3, right? So I'm going to say it went down 3. The steepness, though, which line is steeper? Well, you can't really see it until you get up here. And then you can see that if I was a snow skier, this line, let me make it a little straight, this line's a little bit steeper than the parent function. So I'm going to say what happened to the steepness? It got steeper. And now the y-intercept is moved. So, just a reminder, when you have a f of x, and this value right here, if a is bigger than 1, it's going to get steeper, which if you look here, 4 over 3 is bigger than 1, so that's why it got steeper. And if you have a f of x, and a is a fraction, oops, that's an a, that's the one. If a is a value like a decimal between 0 and 1, we're going to say it gets less steep. Yeah, there's not much to this review. We'll be done here in just a minute. Alright, now we're going to do equations of a slope. Oh no, we're not actually doing that. Equations of a slope of 0 under fine. We already worked on that. You do not have to do that one. I don't know if that's on your review. It happened to be on mine. Alright, let's look at correlation coefficient. Describe the correlation. If I were to draw a line of best fit through this, it would be a negative correlation. The temperature outside and the number of coat cells. Do they correlate? Yes. Does one cause the other one? Yeah. The colder it is, the more coats you're going to sell. So I'm going to say there is causation and correlation. Let's see, the age of a person and the number of books they read yearly. No, I mean, you might say that when you're younger, you get a lot of books read to you, but you don't actually, read the books. As you're older, I guess sometimes you read more books, but maybe it correlates, but it doesn't have causation. There's correlation, but there's no causation. The number of pencils sold and the amount of money made. Okay, the more pencils you sell, the more money you're going to make. So there's definitely causation there. The pencil sales are causing you to make more money. Alright, the correlation coefficient for the 6 scatter plots shown below are as follows. Match each scatter plot to the correct correlation. Okay, I'm going to start here. I'm going to switch to red so you can see a little better. This is a very strong positive, right? So what's my strongest positive? Right here, 0.99. So I'm going to say this is 0.99. Okay, I'm going to look. Here's my next strongest positive. So I'm going to look and I see over here I have 0.9. I'm going to say that's probably 0.90. Now I'm going to look for a negative because that's usually my next easy one. That is a pretty strong negative. Negative, I've got 0.85 and 0.4. It's pretty strong, so I'm going to say 0.85. Let's see, this one, this one's kind of going down as well. I have 0 correlation. You know what, I'm going to say this one's probably 0. And this one right here is going down, so I'm going to say this one is negative 0.40. This one, I would probably say it goes up. This one would be positive 0.50. That's where I'd go. Alright, categorize the following as strong positive, strong positive, weak positive, strong negative, or weak negative correlations. Okay, I'm going to use abbreviations. I'm going to do strong positive, weak positive, strong negative, or weak negative. Okay? I'm going to do my strong positives first. I'm looking for things that are strong positives. So this would be a strong positive. I'll put POS. Let's see, we got any more big numbers? We got this one right here. This would be strong, but it would be a strong negative. Okay. Well, 0.12, that would be very weak, because remember, we're thinking about it like a dollar. It's positive, so I'm going to say a weak positive. This one right here would be very weak, but it's a negative. Right here's another weak one, and it's a positive one. Here's another weak one, and it would be a positive. So let's look here. This one, if I have to say positive or negative, that part's easy. If I have to say strong or weak, I'm bigger than 50 cents, so I'm probably going to say it's a strong negative. I might say it's more of a moderate negative. It's kind of in the middle. This one, I'll go ahead and say is strong, but I'm going to say this one is a positive. This one is a negative. It's bigger than 5, so I'm going to call it strong. Moderate is probably the better word for that one. But anyway, kind of get the idea. All right. Use the equation of the line of best fit. All right. Find the correlation of the following. Use your calculator. Remember to turn the diagnostics on. Okay, so it wants to know the R value and it wants the equation. So we're going to go into our calculator. We're going to go to Stat. We're going to go to Edit. And I got to clear this out. I'll move it up. Hold on one second. Okay. So I'm going to plug my values in. If you do not have a calculator, you can let me do it for you. I'm just plugging all these values in. You want to make sure they line up correctly. Alright, so once you do that, you go back to Stat. We go over to Calculate and down to number 4. We're going to enter all the way through until we get to Store. We want to do alpha y equals, and we want to do the y bars right here. And store it in that y1. Enter all the way through. Alright, so here we go. So let's write that equation. So y equals ax plus b. So 0.234. I'm going to round 6 up to 7, put my x, plus 2.979, and I'm going to round that 5 to a 6. I do 4 decimals. My R factor is 0.2346, so it's about right here. Oh, I need to make sure I do that positive. And you can look and see how we're just a little bit off. That's because correlations don't always stack up exactly. Alright, so now we've got the next one. So we're going to go to Stat, Edit. I'm going to go up and clear all this mess out. And I'm going to put in the next one. So I'm going to put in 6, 7, 5, 4, 3, 1. And on the other side, negative 1, 9, 2, 3, 4, and 7. Same thing. We're going to go to Stat, Calculate, number 4. We're going to alpha y equals, and we're going to store that over in the y bars. I'm going to leave that there for a second and let you do it. Pause your video if you need to. I'm going to move on to the next one. Alright, so Stat, Edit, move up and clear, move up and clear. Okay, so I'm going to remember, oh, you know what? This is not years, is it? This isn't 1900 like they normally do. They actually gave me the years after. So I'm going to actually plug this one in just like it's written. 50, 60, 70, 80, 90, 100. 29.6, 33.4, 38.1, 42.5. Alright, so there it is. They want the correlation coefficient and they want the equation. So I'm going to hit Stat, Calculate, number 4, enter all the way through. On Store, I'm going to do alpha y equals, store it in y vars, and there's your numbers. And I believe that is all we have on the review. It's a very short review, y'all. Thanks for watching.